Nuclear power currently produces around 14% of the world's electricity and 6% of the world's energy. Nuclear power is very controversial because of nuclear accidents that have occurred over the years. Notable examples include the Chernobyl disaster in 1986 and the more recent Fukushima disaster. Another major problem with nuclear power is the disposal of radioactive waste. There are a couple of effects that nuclear power has on the environment. These effects are creating spent nuclear fuel, producing uranium tailings at mines, releasing radioactive isotopes during operation, and releasing large amounts of radiation during accidents. This video will primarily focus on number 1, creating spent nuclear fuel, because that's the waste product which must be disposed. Uranium tailings are also waste byproducts, and they are created when uranium is mined. When uranium is extracted, leftover radioactive sand remains. If this stuff isn't properly disposed of, it can make its way into our food chain and into our water. Nuclear reactors use large unstable atoms such as uranium-235 or plutonium-239. When these atoms are hit with a neutron, they undergo nuclear fission. This causes them to split into 2 or more smaller atoms and release energy, gamma radiation, and more neutrons. These neutrons then create a nuclear chain reaction. So let's use uranium as an example. When it absorbs a neutron, it undergoes nuclear fission. The atom splits into 2 different atoms, krypton-92 and barium-141, and releases 3 more neutrons. Uranium-235 doesn't always split like this, but all possibilities have similar results. 2 or more lighter atoms are formed, gamma radiation is released, and 2 or 3 neutrons are released. Radioactive waste contains highly dangerous radioactive isotopes. These radioisotopes have unstable nuclei and release energy and subatomic particles as they decay. This radiation can be dangerous if it finds its way into the environment. However, radiation in general isn't always dangerous. Radiation is almost everywhere. For example, the sun emits cosmic rays, and the human body contains radioisotopes like carbon-14. It's exposure to large amounts of radiation that is harmful. So now let's go back to talking about spent nuclear fuel, which is the waste created by nuclear reactors. The radioactive isotopes in the waste are extremely dangerous. To add some credibility to this, a professor at the University of Singapore had said, "These elements include more than 100 dangerous radionuclides and carcinogens, such as strontium-90, iodine-131, and cesium-137, which are the same toxins found in the fallout of nuclear weapons." Radioactive waste has 2 main categories, low-level and high-level waste. Low-level waste basically includes stuff that were used to handle radioactive parts of nuclear reactors and medical equipment used in radioactive treatments. This includes paper, clothing, rags, tools, and parts. Low-level waste contains only a small amount of radiation, and it's not incredibly dangerous. Most of it isn't any more dangerous than if it was used regularly. Low-level waste is either stored or buried for 10 to 50 years to allow the radioactive isotopes to decay. It's usually incinerated or compacted to reduce its volume and then buried in landfill sites. High-level waste is the really dangerous stuff and is usually in the form of spent fuel rods. People are still not completely sure of how to deal with high-level waste as their radioactive isotopes have extremely long half-lives. Iodine-129, for example, has a half-life of 15.7 million years. Currently, the best we can do to dispose high-level waste is to isolate it from the biosphere, or the planet's ecosystem, and wait for it to decay. There are many problems associated with storing dangerous nuclear waste for very long amounts of time. Radioactive waste is not easy to deal with. It is toxic and can cause serious harm to humans and animals. It also generates a tremendous amount of heat. Here are a couple of things that engineers have to work around. The waste must not be able to escape to the outside environment through accidents. It must be protected from intruders. It must not leach into our groundwater. It must be able to survive natural disasters, such as earthquakes. And it must be monitored periodically while it decays for hundreds of thousands of years. For the first 10 to 20 years after they have been used, spent fuel rods are kept in storage pools at the reactor. The fuel rods are kept underwater to cool them and to reduce the amount of radiation emitted. This short-term storage allows the waste to become safer when they transport it to long-term storage areas. Storage pools aren't shielded by concrete walls like the fuel rods in reactors. So, in an accident, they can release large amounts of radiation if they aren't cooled down. This occurred in the Fukushima accident since the pools didn't have any backup circulation systems in place. As a result, a fire started in the facility and the radiation was emitted into the atmosphere. There are three main areas that are possible long-term disposal sites: outer space, under the seabed, and deep underground. Surprisingly, sending radioactive waste out into space has many advantages. It ensures that there is no possibility that the nuclear waste can come into contact with our ecosystem, and it doesn't need to be monitored like the other solutions. However, a major drawback is that given the current state of space travel, this idea is insanely expensive and risky. It would take a lot of energy to escape Earth's gravity and send the waste far away. Also, if an accident occurred, the results would be disastrous. The second option is storing the radioactive waste under the seabed. Burying waste under the seabed is safer than land because it reduces the chances of exposure through seismic activity, like earthquakes. Furthermore, unlike on land, there is little chance that the waste can contaminate nearby groundwater. The problem with seabed burial is the enormous cost associated with digging deep under the hard ocean floor. This makes it difficult and costly to bury, retrieve, and monitor the waste. The third option for radioactive waste disposal is burying it deep underground. One method of doing this is digging a 5-kilometer deep borehole into the ground and lowering large steel storage containers into the bottom 2 kilometers. The borehole would then be filled with either clay or cement. Unlike the other two methods, this one has a risk of contaminating nearby groundwater if an accident occurs. Although it is still fairly unsafe, this method is currently being developed by many countries for future use. All of these methods are extremely expensive and time-consuming. Because of these two factors, governments are often indecisive when dealing with nuclear waste disposal issues. Engineers must plan for the waste to be stored for hundreds of thousands of years. Any cancellations in plans would mean billions of dollars are wasted. Another problem is the social stigma involved with nuclear waste. For example, there is currently no long-term plan for waste disposal in the US. This is because the planned Yucca Mountain repository was recently canceled after being delayed for 12 years. The residents of Nevada felt it was unfair for them to store the waste when they don't have any nuclear reactors in the state. The main fact is that no one wants nuclear waste in their backyard, no matter how safe it is. Unlike the US, Canada currently has a long-term radioactive waste disposal plan. The plan is to create a centralized, deep geological disposal area to isolate all radioactive waste from Canadian nuclear reactors. The Nuclear Waste Management Organization is currently in the process of selecting a suitable location for the project, most likely in the Canadian Shield. The plan will have 3 phases. Phase 1 would be to use dry storage casks to store spent fuel rods until they can be shipped to the centralized location. Phase 2 involves digging into the ground and demonstrating the capabilities in a smaller scale. Finally, Phase 3 involves the containment and isolation of waste as well as monitoring. In summary, the disposal of nuclear waste is still fairly primitive and has many serious problems. Firstly, radioactive waste is very dangerous, especially within the first 10 years. Some radioactive isotopes take millions of years to decay. Current methods of disposal are expensive and time-consuming. Also, waste must be monitored periodically. Engineers must take into account accidents and natural disasters. Finally, there are risks of contaminating the environment and groundwater.